Energy efficiency. The sustainable solution to the energy crisis in developing countries. 1. Energy efficiency. 2. Benefits of energy efficiency. 3. EAS and pay-as-you-go models, the problem. 4. Making energy efficiency work as the prerequisite. 5. The Energy Efficiency Audit and Assessment Playbook. Introduction. Whilst Europe and the Western world have set targets to go carbon neutral by 2050, the third world countries are oblivious. As usual, they don't see what goes on until it's past. Achieving the zero carbon status might be a long stretch for those in pursuit, particularly as embedded carbon is still an enigma. What can, however, not be denied are the positive impacts this venture will have on their environments and energy economies. Attaining carbon neutrality not only needs political will, but it also requires financial capabilities too. Elements that are far and few in the third world countries. But I say, if we don't have the muscle, we can leverage on the brains. On face value, we could easily point corruption and the lack of political will as the major reasons for the energy crisis in developing countries. A closer review will, however, expose a greater depth to the wroth. And whilst we can trade blames forever on the negligence of governments and governmental institutions in finding smart solutions to energy problems in these regions, the facts do clearly show that approach is more of a problem than intent. We have a theory that sees energy efficiency as a compulsory prerequisite to renewable energy deployments, before optimal value can be gotten from grid installations in third world countries. This is a proven technique for energy savings, carbon reduction, and energy sustainability. And the UK Retrofit Initiative is a testament to this. Currently, in developing countries, emphasis is mostly placed on grid deployments. Having massive energy potential from the sunlight doesn't necessarily translate into successes in solar photovoltaic grid installations. And the third world countries are fast realizing this. As stated earlier, we don't have the financial muscle of the Western world. But what we're not in short of is skills adaptation. The retrofit agenda in the United Kingdom, though produces the desired energy results, could at times be very capital intensive. And capital is what we don't have in developing countries. Even when the capital is available, some other unsavory uses are found for them. This then highlights the need for tailored energy efficiency approaches that would be applicable for third world countries. For starters, in developing countries, social amenities are often provided by the citizens themselves, with governments lacking in their basic responsibilities. Hence, it is unfeasible to expect homeowners to single-handedly retrofit their homes, knowing fully well that the costs applicable would be enormous. In this course, we'll outline simple ways through which technicians, energy consultants, individual homeowners and businesses in developing countries can apply energy efficiency initiatives before renewable energy installations are deployed. This will not only guarantee energy savings and the smarter use of energy, but will also start us on our own national quests to carbon neutrality. Energy efficiency. Energy efficiency is a part of the energy management process. We could broadly define energy management as a combination of energy conservation and energy efficiency strategies. Energy conservation is an intentional effort to reduce the quantity of energy being used at a given time. This could be as little as ensuring that you switch off your electric gadgets when they're not in use, or minimizing the use of some electrical gadgets with the sole aim of conserving power. Energy conservation is always seen as a quick-fix approach and is directly within the control of the energy user. Energy efficiency, on the other hand, sees a long-term goal in sight. The agenda here also is energy savings, but the route incurs an expense. You can consider this initiative as a spend-to-save model. In energy efficiency, the goal is not to minimize the use of gadgets, but rather to look for gadgets that would consume less power. This option is smarter, more efficient, and ensures sustainability. Let's now review 3 of the main reasons why energy efficiency is sacrosanct to the sustainability agenda. Cost. It's global knowledge that energy costs have been on a steady rise. The fact that a group of oligarchs get to decide energy prices for the whole world keeps everyone subject to price manipulations and the private economic agendas of the few privileged. Most conventional energy sources are not renewable. Hence, the fear of depletion perhaps sets the undertone for the constant hike in prices. Now, renewables have come on board. And though renewables offer a longer-lasting alternative, the capital-intense nature of these installations still demands that common sense be applied in the use of energy. Security. Fossil fuels are not renewable. And though there's a global drive towards renewable sources, several countries and economies are still dependent on the conventional sources of energy. Until we can move the whole world to renewables, there must still be a model to guarantee the continued sustenance of the world's energy needs through the available sources. Energy efficiency is this model. Pollution. Environmental factors have been integral to the push for energy efficiency. The damage climate change is causing to our planet is global knowledge, yet some are still engrossed with their own energy needs, and that against the greater good. It is therefore imperative that energy efficiency initiatives be adopted to reduce the rate at which greenhouse gases, GHGs, are pumped into our atmosphere. The application. Energy efficiency initiatives can be applied in residential or commercial buildings, particularly in these areas. 1. Lighting. This includes all light fittings and bulbs that provide illumination. 2. Air conditioning. Here are all gadgets that provide cooling for the home during humid temperatures. 3. Heating. This is required in colder climes, when the heating of a building is needed during autumn and winter seasons. 4. Ventilation. Seen as an alternative to air cooling in some cases. There are some building installations that allow for ventilation, particularly to ease off the effects of heating during cold temperatures. 5. Equipment. Applicable for offices. IT equipment and gadgets have significant impact on energy consumption in homes and business premises. To this tune, energy efficiency initiatives will help to significantly control energy usage. Understanding electric power measurements. Watt is the rate of measurement used to quantify energy usage. 1000 watts W equals 1 kilowatt kW. For example, suppose we get an air conditioner that is labeled 2000 W. Expressing as kilowatt, the air conditioner could be rated as 2 kilowatts. When rating energy usage in the measure of time, it is measured in kilowatt-hour, kWh. For emphasis, if our sample air conditioner, labeled 2 kilowatts, works for 1 hour, that appliance would be said to have used 2 kilowatt-hours of energy. To appraise the total energy usage in your home or business, refer to your electrical power bills and review your monthly or yearly consumption in kWh. Benefits of energy efficiency. Let's now consider some of the benefits of adopting energy efficiency initiatives. 1. Smart energy usage. Remember, I highlighted earlier that energy efficiency is not shy to incur costs necessary to achieve a planned energy usage objective. An example of this is if you currently use a fridge that is rated 2000 W. Suppose the cost of energy from your supplier is $5 per kilowatt-hour. When you use your fridge for 10 hours in a day, you'd have incurred 20 kilowatt-hours, 2 kilowatts 10 on the appliance after that 10-hour period. Now multiply that figure to the price per kilowatt-hour equals $5 20 kilowatt-hours. Equals $100. Giving the excessive energy cost incurred on the fridge, a smart energy efficiency initiative will see you buy a new fridge that is rated 500 W, thereby saving you 1500 W. Though the purchase of this fridge temporarily poses an additional expense, A payback period calculation will show you the energy savings you've made from the purchase over a certain period. NB. Refer to Chapter 7 to refresh your memory on some of the financial calculations applicable. 2. Curbs waste. Perhaps one common variant that unifies most developing countries is their mismanagement of national resources. Having something available in excess quantities shouldn't imply that it must be misused. This doctrine also applies to energy usage. Let's take an example. If there are 50 homes in an estate that is powered by a mini-grid, suppose on the current appliances usage in those 50 homes, monthly power consumption from the grid is 20 milliwatt-hours. If all these homes decide to upgrade their appliances to energy-efficient ones, power usage in those homes will significantly drop. And this will have a considerable effect on the total power consumption in the estate. As a resultant effect, there would be more power left on the grid for probable supply to other needing estates or communities, which would help to generate income. 3. Reduces demand on grid. When energy is efficiently used, the general demand on the grid is reduced, and this improves the life expectancy of the installation. Let's consider battery storage systems. Round-trip efficiency and Dodds depth of discharges are significant to the workings of battery storage systems, particularly as they directly influence the useful time of the systems. The round-trip efficiency of a battery relates to the amount of energy that can be used from the battery, with regards to the amount that was initially stored. High round-trip efficiency metrics usually relay optimal performance. Dodds, on the other hand, requires that batteries retain some of the power they receive. For example, if a battery holds 10 kilowatts of energy, it is expected that the power you draw from the battery doesn't exceed 9 kilowatts, to allow for a 10% residue. If energy drawn from batteries exceeds this quantity due to excessive demand, the useful life of the battery will be drained out, and its durability will be compromised. Heavy energy demand on the grids due to energy-inefficient appliances will negatively affect the durability of mini-grid installations. This is why energy efficiency is imperative for adoption in homes and business premises. 4. For operational efficiency. This particularly applies to businesses. The golden rule of business operations states that the fastest way to improve profits is to reduce costs. And whilst cost reduction might be a little tricky for most operational duties, due to the possibility of quality compromise, energy use presents a very viable opportunity for savings. Adopting energy-efficient strategies will not only help businesses know their energy data, but will also help to have firm control over them. Inefficient energy use in organizations are like leaking holes in pockets. To save costs, these holes have to be plugged. Smart companies set energy performance targets as a direct initiative to curb unnecessary energy expenses. 5. For CSR, corporate social responsibility. In our world today, customers are becoming very savvy about the environment and are starting to hold organizations accountable for their activities that directly impact our world. Smart companies do not only ensure that they're environmentally compliant, they also make sure everyone hears about it. When an organization institutes energy-efficient policies, it shows commitment to reducing GHGs in our atmosphere. It also reveals a sense of corporate responsibility that showcases the gold standards evident in that organization. EAS and pay-as-you-go models. The problem. The deployment of renewable energies in third-world countries are advancing at a crawling rate. Most of these countries cannot, with their national grids, cater for the energy demands in their countries. The renewable sources would have been a great way to augment the current supplies, but the instituted leaderships of these countries do not have the political will to embrace this solution. Despite the availability of the sun as an unlimited resource, several factors have inhibited the mass powering of homes and businesses using this alternative source of energy. Chief, On the obstacles to the success of this drive in the developing countries is the lack of structures and funding from governmental agencies. But apart from this obvious impediment, subtly creeping in as an agent of apathy is the proliferation of the energy sector by quacks and poorly trained personnel. Currently, most homes and businesses in developing countries fund mini-grid installations from their personal pockets. Very few banks venture into energy business funding for consumers, due to the risk attendant. This then subjects the energy consumers to heavy capital commitments. You can now understand how frustrating it will be for consumers to have installations that don't work optimally for the time period expected. Ignorance and a poor skills base have resulted in several failed energy projects. And this has also resulted in energy consumer apathy. Perhaps the absence of effective standards monitoring in developing countries has also encouraged the influx of amateurs into the sector. PV panels have poorly performed due to technical errors during installations. Some homes have even had fire outbreaks owing to faulty wirings. The gross ineptitude and overwhelming incompetence of many technicians have made renewable energy an unreliable alternative to many energy consumers. Apart from the unprofessionalism in the sector, the greatest deterrent to renewables in developing countries, by a long stretch, is still the huge financial implications that renewable energy deployments invoke. And to provide a suitable alternative to consumers who don't have the resources to meet with the required obligation, many energy companies are now implementing the EaaS business model. EaaS is known as the Energy as a Service model. The model allows energy consumers pay for energy services without needing to make huge capital investments on the energy assets. It's a form of pay-as-you-go type of subscription that gives customers access to the energy supplied from the installed grid without having to procure the energy assets. And whilst this model might appear as a viable alternative to solve the energy crisis in developing countries, its sustainability is in doubt. And this is owing to the following reasons. NB. Our sustainability metrics for this model is measured by the reach, the feasibility, and the durability. Pricing. The EaaS business model might make energy available to consumers, but it is very capital intensive for the energy companies. Huge investments are required to install home grids for each of the customers, whilst the hope for financial returns is subjected to a payback period. Perhaps this is why the few energy companies currently practicing this model place high premiums on their services. The consequence of this is that only the rich can have this service, as it's beyond the pocket range of middle and low-income earners. In this regard, EaaS meets the need of only a fraction of the needing populations. It doesn't solve the energy crisis in each of these nations. Neither does it provide the prospect of sustainability. Logistics. In the EaaS model, energy companies are primed to deploy the grid assets at no cost to the consumer. This model will, however, only be feasible if the consumer has a good location for the assets to be installed. Most home grids require that the deployed assets be resident in the building premises of use. PVs are mounted on roofs. Batteries and inverters also require secure locations within the premises. These stringent requirements then limits the number of consumers that would be vetted for such contracts. Popular in developing countries is the high rate of poverty. A considerable size of the national populations in third world countries live below the poverty line. Hence, it is unlikely that energy companies will find lots of consumers who meet the space and site specification requirements. Legal complications. As described, the EaaS model is premised on the availability of secured locations within the consumer's premises. Another major problem that would arise, as this model increases its operational range, are the litigation issues that could crop up if the safety and security of the deployed assets get compromised. Whilst signed contracts might seek to hold the consumer directly responsible for the security of the grid assets, the question of who holds liability when the assets get damaged in unforeseen incidents still poses a conundrum. The technicalities involved in the protection and monitoring of grid installations might prove too complicated for many consumers who hope to one day embrace this model. NB. Using our sustainability metrics, which measures the reach, the feasibility and the durability of the model, below are the summations. For durability, the EAS and pay-as-you-go systems score a pass mark. The huge premiums, litigation worries and deployment location constraints, however, put the reach and feasibility scores of this model in doubt. Making energy efficiency work as a prerequisite. Giving the perceived challenges with the sustainability of the EAS model, the smoothest path for resolving the energy crisis in developing countries is to revert back to consumer-led private installations. But these installations must only be done after an energy efficiency audit and assessment of the premises. Before we go further, let's review the roles to be played by the governments of these developing countries and their institutions in this strategy. In most third world countries, daily social amenities are self-provided by the citizens themselves. The instituted governments in these countries don't have the resources to sponsor the massive projects that will ensure adequate supply of energy. The governments can, however, help in the following ways. Standards monitoring. This has to be addressed, and addressed immediately. The ministries of power and energy resources in all developing countries must put processes in place that allow only certified professionals practice energy service deployments. Even for those who are certified, the concerned governments should, in coordination with professional associations, institute developmental and TOTS, train the trainers programs that will build capacity in the industry. Subsidization of energy equipment. The fact that most of the assets required for renewable energy grid installations are imported from the more developed countries is not in doubt. Even in rare cases where some developing countries manufacture parts of these energy equipments, there are still some vital pieces that are subject to foreign imports. To address energy crisis in developing countries, constituted governments in these countries must aid the drop in prices for these equipments. It's recommended that they provide import subsidies. And in cases where the governments cannot afford the subsidies, tax reliefs could also be a welcome development. As the central note of this book, it is recommended that energy efficiency audits and assessments should precede any renewable energy deployments. This is the strategy that should be adopted by technicians and consultants in the industry. A detailed overview of the energy efficiency audit and assessment process is shown in the next chapter. The Energy Efficiency Audit and Assessment Playbook. Energy efficiency process for technicians and consultants. NB. Most quack solar installers just ask for the number of rooms in the premises or apartment, the number of and type of appliances, etc. This playbook, however, encourages energy audits using the client's energy data. Initial review. Review the client's last annual energy bills. Compare the revealed costs and efficiency to that of similar homes, business premises. Take a review of the past 1 year. Site assessment. Interview the client and walk through the home business premises. Conduct a physical inspection and collect all relevant data. Energy and cost assessment. Compare data from the client's utility bills to the data gathered from the physical inspection. Use that information to estimate improvements and savings. Report and recommendation. Give client a summary of the audit findings and show the problem areas. Make recommendations for energy-saving measures. Things to watch out for. 1. Wasteful lighting. Light fixtures and poor wirings can be a major source of energy consumption. Incandescent light bulbs use a lot more energy than the LEDs. Rewiring may be needed if the home fittings are compromised. 2. Inefficient appliances. Some equipments consume a considerable amount of energy. Check the energy ratings to see the ones that aren't energy efficient. Appliances you should check are refrigerators, washing machines, air conditioners, and water heaters. These appliances use up more energy than others. Areas to review. Lighting. Heating. Ventilation. Air conditioning, NB 1 horsepower equals 746 watts. IT equipment. Any other. What to do after the assessment. Discuss observations with client. Ask client if they have any questions and inquiries. Ensure that the client understands the discovered problems and your proposed solutions. ONB. Replacing incandescent bulbs with LED or fluorescent lighting can lead to an average of 40% in energy savings. Replacing inefficient equipment and appliances with efficient ones can give you 30% in energy savings too. The information you derive from the above processes will enlighten you on what off-grid system the client requires and the capacity. Summary of steps. 1. Carry out an energy assessment. Advisory and recommendations must precede every off-grid installation. 2. Visit site, take plenty of notes and photos. 3. Ask for energy bills and floor plans, if any. 4. Review the power bills over a period, notably 1 year. 5. Highlight trends seen from number 4 above. 6. Show an analysis of where the most energy use is from, lighting or cooling, etc. 7. Recommend capacity load for the off-grid installation. 8. Calculate payback period for your recommendations. 9. Calculate ROI. 10. Calculate LCOE, so that client can know the cost of the energy to be gotten from the planned off-grid installation per kilowatt-hour. 11. Have closing discussions with company staff or owner-occupant. 12. Provide summary report to client. 13. Embark on project. Energy efficiency audit and assessments must be first at all times.